Hello everyone, I have this problem for you today. It says, find the volume of a sphere with radius 3 using spherical coordinate integration. So some things you need to know before you do this is that rho squared is equal to x squared plus y squared plus z squared. That's the same thing as like r squared is equal to x squared plus y squared for a circle. For regular coordinates, we know that I lost it. Okay, we know when you plot something in Cartesian coordinates, we use x, y, z. Now, if we want to do it in spherical fashion, we use rho, theta, and phi. Phi is like the radius. Theta is the xy angle, the angle on the xy plane, and phi is the angle on the yz plane. You can see that better if you look at my diagram right here. You have xy plane, that's where theta is. You have yz, that's where phi is. And then rho and z are both equal to each other, but r is the xy axis and rho is on the yz axis. Okay, so the problem is finding the volume of a sphere where r, the radius of it, is equal to 3. Alright, let me scroll to the left. Okay. So the way you want to set up this integral is we first need to know the domain. So this is the domain. You have a function of rho, theta, and phi. And for rho, we know that's 3, so we're going to integrate from 0 is less than or equal to rho, is less than or equal to 3. For theta, we're going to go from 0 is less than or equal to theta, is less than or equal to 2 pi. We want to go all around because we're using a sphere. And then for phi, we have 0 is less than or equal to phi is less than or equal to pi. Phi only goes from 0 to pi because if you go over pi, you're just adding more. You're adding more than what's what it's supposed to represent. So to set the integral, we use it's a triple integral, and we go from, first of all, when we do a sphere, we put x squared plus y squared plus z squared, and then we add this when we do spherical coordinate integration. We add p, and then it's actually p squared, and then it's cosine p squared sine phi is what you add, and then the order of integration is phi, so d phi, d theta, and d phi. So since we're doing phi first, we're going to go from 0 to pi. My bad. That's actually for the middle one. That's for the last one. So rho. Oh, I see right there. That's where I messed up. This is supposed to be rho right here. So let's change that to rho. So we go from 0 to 3, and then for theta 0 to 2 pi, and 0 to pi for the next. Okay, so far so good. So we know that x squared plus y squared plus c squared is equal to rho squared. We're using that because we're using a sphere. I'm going to cut this bottom piece out to do the calculation. Alright, so I'm making this rho squared, so that gives me, I'm also going to write the phi and theta integrals as separate from the rest because we can evaluate them right now. So d theta, that's going to be 0 to 2 pi. The next integral is 0 to pi, but it's d phi. And then we know we get rho to the fourth here times rho to the second, and then don't forget that for this one, d phi, we also need sine. I'm going to write that, I'm going to move this over a little bit so I have room to do that. So I slide this piece over here, and then this piece out here, and then it's sine phi, sine phi. So if I integrate d theta right here, that just gives me theta, and I evaluate that from 2 pi to 0. And then sine phi is negative cosine phi, evaluated from pi to 0. Now the last one is, we can evaluate that too, that's rho to the 7th over 7th. Evaluate it from 3 to 0. I'll scroll down a tiny bit. Alright, I'm going to make some room for myself. So I'm going to get rid of this piece up here, and I'm going to pick off right here. So let me make this look more aesthetic. Okay. Alright. So this is just 2 pi, the theta one, because that's all you have. If you put 0, you get nothing. For minus cosine phi, you get negative 1. So the 0 part minus cosine of 0 is 1. So we have minus 1. And then for rho, it's going to be 3 to the 7th over 7. Okay, let me do that calculation. 2 pi times 3 to the 7th over 7 times, so negative 1 minus 1, that would be negative 2. Okay, I just did put into a calculator, and the answer came out to I should also put a 2 and a okay. I get 3,926 units cubed. Alright, this is how you find the volume of a sphere given the radius using spherical coordinate integration. Have a good day. Good luck.